Hi friends, welcome to our channel. Let's have a look at problem 39, 17. Count indices with opposite parity. So here basically we are concerning about the oddness or evenness of the numbers, right? So the score of an index I is defined as the number of indices such that the indices is larger than I. In other words, is to the right, and the number I and number J have different parity, right? So we want to return an integer array of length n, where n is the length of the array, right? Where answer I is the score of indices I. In other words, it's a number of different parity numbers to the right, right? So if you see this one, it's the 1, so you have 2 and 4 to the right, so you have 2. If you see 2, right, you have 3, so you have 1. If you see 3 and you have 4, so you have 1. And then you see 4, the rightmost, so they're always being 0, right? So this problem, because it's a very small size problem due to the first constraint, right? So we can use a very brute force solution. But here we're going to use the sum, right? So we're going to use the count. Essentially, we're going to count a number of ones and zeros. So here we are using ones and zeros corresponding to parity. 1 is odd and 0 is even. So this way, the sum will be the total number of ones, and then the length minus sum will be total number of zeros. So this way, you just need to iterate once after you get this information. But in order to elucidate this idea, so I'm going to first use a for loop to do a list comprehension to get a 0 and 1s. But in reality, you don't need to do this. What we do here just for pedagogical purpose, right? So y modulo 2 for y in nums. So in other words, for this number, you're going to get 1 0 1 0, right? So you can print out that just to have a look, right? So you get 1 0 1 0. So once you have this this step, then first you can get the total number of ones, total ones. So that will be the sum, right? Then the total number of zeros will be, let's introduce a length. Let's see, n equals length on nums. So that will be n minus total ones, right? So then we just need to initialize a result. So you can initialize a result of length n, and then you do an assignment, or you can just append, right? So here I'm going to use append. Then first, the number of zeros we send zeros. So we are going to start. So we have 0, and the send ones we also set to be 0. Then we just iterate. So for I in range m. Or if you like, so you can also just for this problem, you can also do, say, for y in ox, right? So basically, you don't need to do the index. So then what we are going to do, we are going to check if y is 1 or 0. If it's 1, right, so we want to count the zeros to the right. So what that will be, so let's see, the result will append the total zeros, right? So it's total zeros minus sin zeros. Because the current number is a 1, so we're going to update sin ones by 1. Otherwise, so y will be a 0. So we are going to count the right ones. So we're going to check the ones to the right. So it's total ones minus sin ones, right? So because this number is 0, so we're going to update the sin zeros increment by 1. So what we want to return is just the result, right? So as I mentioned, let me first do a check and submit that. Yeah, it passes all the cases. So as I mentioned at the very beginning, so you don't need to specify this list, and you can just iterate and then do this thing, or you can have this in, and then you do a list comparison to get the total ones, the count of even number or odd number, both are okay. Then you do a for loop, right? But here we want to demonstrate the thought process to you, and this problem is itself very straightforward because it's marked by easy indeed. But for some easy problem, if you practice more and more, you can summarize a lot of your own thoughts, your own patterns, and it will help a lot to solve more advanced problem. With that said, I guess that's the end of this video. Thank you for watching.